Hello, this video is about homework 1, question 3. Now, question 3 was confusing to quite a lot of people, and that's fine because the integers mod 6, this was a question about the integers mod 6, and the integers mod 6 are a bit strange compared with the integers, so they take a little bit of getting used to. So let's talk about the first part, which was square roots. Now, you might have been a bit surprised by this definition of square root, but what's a square root in normal life? In normal life, what is the square root of y? Well, it's some number x. It's some x such that x squared is y. Right? So that's what this definition of square root here is. X is said to be a square root of y when x squared equals y. Okay, so the point is that if you're in the integers, for example, how can you tell which are the things with square roots? E.g., in the integers, how can we tell which numbers have square roots, i.e. r squared? It's the same thing. Having a square root, and being a square is the same thing. Well, what are the squares in the integers? There's 1, right? There's 4, there's 9, there's 16, there's 25. How am I working this out? I'm doing 1 squared, and then I'm doing 2 squared, and then I'm doing 3 squared, and then I'm doing 4 squared, and so on. So we can, in a kind of trial and error-ish sort of way, find all the square roots just by going through all the numbers and squaring them. We can just try it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So in this table I've drawn here, which are the numbers that have square roots? Well, it's these ones, right? These are the numbers that have square roots. So if we're going to do this in Z6, we can do this in Z6, we can do exactly the same thing. In Z6, the numbers we have to square are 0, 1, 2, 3, 4, and 5. And if we square them, right, we can't test every single integer and find its square, but we can do this in Z6 because there are only 6 elements. So what are these squares? 0 squared is 0, 1 squared is 1, 2 squared is still 4, 3 squared is 9, but what is 9 congruent to mod 6? That's congruent to 3. Okay, 4 squared is 16, what's that congruent to mod 6? Well, 2 6s are 12, so we get 3 left over. And what? That was a complete load of rubbish. 4 4s are 16. 16 minus 12 is 4. So 4 squared is 4. And 5 squared is 25. What's that mod 6? Well, 6's go up to 24, so we get 1 left over. So 5 squared is congruent to 1 mod 6. So in this table, which are the numbers that have square roots? Well, it's these numbers. These are the ones that have square roots. You can see what their square roots are over here. And so the answer to this question is 0, 1, 3, and 4 have square roots. So in Z6, 0, 1, 3, and 4 have square roots. Okay, what are their square roots while we're here? Well, the square roots of 0 are just 0. The square roots of 1 are 1 and 5. The square roots of 3 are just 3. The square roots of 4 are 4 and 2. These are the square roots. These are the square roots. Now, when you're in normal life, how many square roots do you expect each number to have? You expect every number to have 2 square roots, apart from 0. 0 only has 1 square root, right? Because usually you have the positive and the negative square root. But 0, the negative of 0 is 0, so it's a sort of double square root. Now the same is happening here, look. This is really plus and minus 1, right? That's plus 1 and minus 1. So this here is really plus and minus 1, which is what you expect for the square roots of 1. And this one here, this is really plus and minus 2, right? And that's what you expect for the square roots of 4. And what's this? Well, this is actually plus and minus 3. It's just that plus and minus 3 in z root 6 happen to be the same thing. So this is in fact plus or minus 3. So they've coincided and collapsed on themselves, which is why it looks a bit funny. Okay, now let's do question 2. Have we got time? Probably. Part 2 of this question is to find all the solutions of x squared plus 3x plus 2. X squared plus 3x plus 2. So we're going to look for x such that x squared plus 3x plus 2 equals 0. So what you can do in normal life is you can factorize this. Okay, usually you could say that this was a pair of factors and that you could find 2 solutions. But that doesn't work in Z6. And we're going to see in lectures, or we may have already seen in lectures, why that doesn't work in Z root 6. And if you just try, by trial and error, let's just try it. So let's make a little table. 1, 2, 3, 4, 5. Fortunately, Z6 has few enough elements in it that we can just plug each one into this and see if we get 0. If we do get 0, that means that the thing we just plugged in is a solution for this. Okay, so let's fill in what x squared plus 3x plus 2 is. Well, for 0, it's easy, we just get 2. Right? For 1, we get 1 plus 3 plus 2, which is 6. 6 is congruent to 0 mod 6. Oh, look, 1 is a solution. What do we get for 2? We get 4 plus 6 plus 2, which is 12. 12 is congruent to 0 mod 6, so that's another 0. So this is a solution. Okay, 3, what do we get for 3? We get 9 plus 9 plus 2, that's 20. 20 is not congruent to 0 mod 6. 20 is congruent to 2 mod 6, so that is not a solution. Okay, 20 is congruent to 2, so that's not a solution. For 4, we get 16 plus 12 plus 2, and that is 30. Is that 30? 28, 30. 30 is congruent to 0, so that's a solution. And for 5, we get 25 plus 15 plus 2. That's 42, that's also congruent to 0 mod 6. So that's also 0. So look, the solutions are all the values of x such that when we plugged them in we got 0. So that's this one, this one, this one, and this one. 1, 2, 4, and 5. Is that surprising to you? Well, maybe it's surprising because usually you'd expect a quadratic equation to have 2 solutions. That's what we're used to, unless they're a repeated solution. But in this case we've got 4 solutions. And the reason that we have 4 solutions is that we're in Z6. So usually, i.e. in the reals, for example, we would say that x squared plus 3x plus 2 equals x plus 1, x plus 2, and we would deduce something from that. We can't do that anymore. So we would usually deduce that x was minus 1 or minus 2, but this fails in Z6. And we'll be seeing exactly why it fails in Z6 later on.